Hello everyone, welcome to the YouTube channel of Striber. My name is Manoj. Today, let us learn about Stribeck curve. What is Stribeck curve? Stribeck curve is basically a curve between coefficient of friction and bearing number, which is also called as RC number. Bearing number can be defined as sliding velocity of the lubricant with viscosity per unit load. Unit load means the applied load divided by the projected area. When we plot a coefficient of friction with the bearing number, what we get are the different domains and the different regimes of lubrication. In this figure, we can see the Striber curve, which is showing us the three lubrication regimes. Initially, it starts with the boundary lubrication regime and then mixed lubrication and finally the full film lubrication regime. This concept of Striber curve is very important for a tribologist to understand about the lubrication regimes of a system. Let us know how we measure the Striber curve. The easiest way to measure the Striber curve is to measure the friction coefficient in a tribo system as a function of speed. This parameter is the easiest to change since there is no need to change the samples or the lubricant. The measurement typically starts from the low speed in order to reach the boundary lubrication regime. Increase in speed results in increase of the central film thickness and the lubrication condition goes towards mixed film lubrication and further to full film. This experiment should run relatively fast in order to minimize the impact of the running in. Alternatively, one could first run in the surfaces and then measure the Stribeck curve. Pin on disc is one of the most commonly used experiments to calculate the Stribeck curve, and the setup of a pin on disc is shown in this figure. Next, let us understand what is running in and impact of running in on Stribeck curve. Running in stage is the initial phase characterized by significant wear loss, variation of the friction coefficient and surface roughness evolution. At this stage, the contacting substrate materials are worn due to local plastic deformation. During the running in, the surface roughness is getting worn and thus parameter increases. This means that the Stribeck curve shifts. In the figure, we can see the impact of running in on the Stribeck curve. Now, let us understand how we calculate the Stribeck curve. There are two ways available for calculating the friction or Stribeck curve prediction in all lubricating regimes. The first one, numerically with the full system of the EHL equations for the rough surfaces. In this case, the governing flow equations, example Reynolds equation, surface deformation equations, are solved numerically by taking the surface roughnesses directly into all the equations. But this approach is computationally intense and consequently has limitations on the size of the computational mesh. The second one is load sharing concept. In this form, it is a simple and load sharing concept can use a central film thickness and it can fit to calculate the lubricant film thickness for the lubrication problem and Greenwood-Williamson model for the dry contact problem. This approach can give a good qualitative prediction of the friction evolution. However, it is likely to overestimate the friction due to the assumption used in both the Greenwood-Williamson model. Here, I have also mentioned the online calculators available on our Striber website for Stribeck curve calculation. This is for the point contact and this one is for line contact. I hope you understood what is Stribeck curve and what are all the ways to measure, calculate the Stribeck curve. These are the references which I have used in the slides, and thank you for watching the video. To get more details on the topics related to tribology, follow us on our social media pages on Instagram, Facebook, LinkedIn, and do not forget to subscribe to our YouTube channel Striber, and also visit our website, that is www.striber.org.